Alright, so I'm pretty much done on the bridge project, and I figured I'd just run through my pride and joy here, which is the pump room HMI panel. So this HMI sits on the one of the motor starting panels downstairs in the pump room. So this is used for diagnostics, used for maintenance. It also is currently shown on the desk to the left of the main operator station. So the operator's got his own screen with like hardly any information, just very simple start, stop, raise, lift, lower, etc. But should be where everything is contained if you want to debug anything. So you can currently this is an overview of the floor plan. And so these are the hydraulic power units. These show you that the transformers down there are on. You can actually zoom in here. So if you're on the panel, you can pinch to zoom on certain things. You can even click certain things and it'll take you to certain places. So I'll take you to the I/O screen. Over here will take you to the hydraulic circuit, etc. I've got the tank temperature like being displayed there, very small, but you've also obviously got all this on the right. So you've got active faults, warnings, motor stopped, the current on each transformer, the tank temperatures, and then where the cylinders are. So currently the bridge is locked up in the air, so the encoders are reading 12,000 millimeters. So if I was to now run the pilot and the boost, you can see here you got the 4 motors running, 8 motors running. You can see the current on each transformer. So if I click that, that takes me to the hydraulic circuit. Yeah. If I run a main motor, it'll show up here green, which I won't do now. Otherwise, someone's going to think I'm moving the bridge. I've got the fault reset button here. I've got a report incident, so you can click this and then say that, let's just say 4 faults active, need to fix faults on tail locks, log the incident, and then that all gets displayed here on the incident log. I think yeah, why does it take a while? I have to click update. That's weird. Okay, cool. Testing incident log, HMI settings, stop the runtime, go to the control panel. Audit trail, which I'm not actually using, but this would be if you wanted maintenance. If the operator wanted to change the value of a tag and you wanted maintenance to approve that. All my alarms, so I've got red alarms for faults and yellow alarms for warnings. And then you can obviously go to the history of the alarms and you can scroll up. So these are all stored on the SD card on the HMI, so you've got a hell of a lot of storage. And then I've got some statistics here. I was planning on expanding this a lot more, but I haven't ever got around to it. So if I stop these motors now, or I'll run them actually and just show you some of the other parts of the software as well actually. So over here you've got motors overview. So this just if you want to stop all of them or go to the main motors. Here, if you're all green here, meaning your circuit breaker's closed, your stop valve's okay, your filters are okay, you've got boost pressure, you don't have any high temp cutouts, as in the tank's not too hot, tank temperature's okay, then you're good to run. If I was to now, for example, I can change the tank temperature by adding an offset. So I've got 40-degree tank temperature. If I make that minus, let's say minus 30 degrees, so now I've only got 10 degrees on my main tank. Here, I've got a blue thing to say that you're too cold, and then if I go onto the main motors, you'll see here now the tank temperature is not okay, so you wouldn't be able to run any of these motors. If I make that 0 again, there we go. Maybe I need a full reset. There we go, yeah, and we're good to run again. And over here, my tank temperature is normal. If I add plus 20 degrees, my tank goes too hot. And actually what happened there is the motors, so because you got a high temperature cutout at like 50, 55 degrees, so tank temperature got too hot, it thought the system thinks, so it shut off those 2 motors there. So I've only got now 4 motors running instead of 8. Make that 0 again. and then just do a full reset. Alright, so I mean, yeah, this one of the great features here is you've got all the I/O screens here, and showing all the analog inputs, so I can see all my pressures. I can even if I change that to 250 bar pressure transducer, I can change that now to a 400 bar pressure transducer and then change the scaler here without having to go into the PLC. So I've got all the I/O for everything all shown here. So yeah, you've got pilot motors, boost motors, main motors, sumps and tail locks. And then from here, I can enable and disable. So if I want on the next bridge lift to only ever use one pump and not start the rest because I want to do maintenance on, let's say, that pump, I can disable that now. So on HPU-A, this pump here now is disabled. And when you hit start all the motors, they won't actually start. So then we've got setup. So here I've got a screen which, when the bridge is moving, you see all these valves turn on, you see the pump loaders turn on, and it shows what demand's going out to all the pumps, 0 to 10 volts, and then the feedback on all the pumps as well. Here I've got a basic lookup table which we're using for wind. So this V110 valve, it adjusts the counterbalance on the bridge. So if it's too windy, pushing it down or up, then yeah, the software uses this lookup table. Got heaters here, electrical switching. So this is if I want the system to fault out at currently 380 volts, then when there's only 380 volts on this, let's go, yeah. When these are reading 380 volts instead of 415, then the system will fault out and it will knock off this transformer, open this air circuit breaker, and start up the generator. So here, these are the main circuit breakers, the air circuit breakers on the system. And then we've got smaller circuit breakers, which are the Siemens 3VAs. So again, obviously all of these are face plated. So when I make a change on any one of them, it changes all of them. And I just pass in all the name parameters and everything. Yeah, I mean, it's yeah, like I said, it's my pride and joy this. So I've got the generator screen. I mean, it's incredible now how fast. So this is the electrical moving screen. It's just incredible how fast I can spin up a HMI now. I mean, this would take me no time. So all I've done here is this is just the electrical drawing that the electrical engineer's done. So he's done all the drawings on E-plan. I've taken the PDF, inverted it, dropped the background off, and then now I've just had to drop on all these text fields with all the currents. So like there, for example, you can see that these boost motors here are pulling 67, 68 amps. You can see the total system usage. So I've got a bit of a discrepancy here in terms of calculation, but yeah, I don't really know what to do with it. That's fine. All right, so you got hydraulics. So again, same thing with the hydraulic circuit. You can see the position of all the valves. So currently on A, none of the main motors are running, and then none of the boosted pilots are running because I increased the tank temperature. So if I go to B, again, obviously all of this is touchscreen. So you can see there, the motors are running. The motors are running, the pumps are turning, and the pump loaders are loaded. And here, yeah. So you can see all your pressures and everything. So if I go to our pilot pressure there, 68 bar. If I go to our boost pressure over here, 10.7 bar. You can see the RPM, 1800 RPM. And lastly, we have the trend view. So this shows our line voltage, currently 400 volts. Our transformer current, so we've got 60 amps on the first transformer, which I guess is like what the building's pulling, and then 160, 180 amps on the second transformer, which is what the motors are running. So on A, we shouldn't have any current, yep, 0, and then on B, we should have some current, yep, 70 amps. So A pressures should be 0. Okay, yeah, we got 70 bar in the pilot line, yeah, because the pilot line's are cross connected. And then B pressures, 10 bar pilot, 10 bar boost, 70 bar pilot. got the encoder positions. And the great thing about this is, so I can go, if I go select time range, I can do 1 day, and then I can start to step back in time. So there you can see, let's go to one where we have some bridge movements. So 14th, 13th of July, 12th of July, just the Friday. There we go. So you can see there, if I zoom in here now, using that. So the bridge is, oh look at that, oof, that's smooth. So the bridge has gone from 0 reading on the encoder and then crawled up from what, 12:58, this was on a Friday I think, 12:58, 15 seconds, up to full position at 13. So just under 2 minutes. It's just, I mean, it's just incredible. This, like, all of this is available on the pump through panel, and then I've also got an engineer area here for some debugging stuff. But yeah, so that is my pride and joy. I think, unfortunately, I did pretty much all of this on site, and so I wish I would have got to sit in the office properly and done this, because I think how much better this could have been. And there's a lot more going on in the background. So I've got it, for example, I've got a shared drive between this panel and the PC upstairs. So all the data logs can get sent to the PC as well via the shared drive. Yeah, there's loads going on here. So yeah, cool. Hope you enjoyed it. And I guess if you wanted to know, this is all done on Siemens WinCC Unified, which I wouldn't really recommend. I mean, I don't think it's that great, but I mean, if you put in work, you can see you can get some pretty good results. And this, I think, all in, I wouldn't say this was more than 5 weeks' work. I don't think. Obviously, I'm on site. I'm doing a whole bunch of other stuff, but yeah, I'd say 5 weeks of software programming from scratch. So I could probably spin this exact same HMI up in maybe 2.5 weeks now, which is insane. So yeah, I mean, hope you enjoyed it. Take care.